What's good, everybody? Welcome to a video on nitric oxide. Now, initially, I'm just going to go over a basic overview of what it is and what it does, and then afterwards, we're going to get into mechanistically at the cellular level what is happening when you take products that increase nitric oxide. Now, nitric oxide is a supplement that a lot of bodybuilders use to get a better pump, meaning that like tight feeling that you feel in your muscles when you lift heavy weights for a while. Nitric oxide is able to improve this feeling by improving blood flow, by actually dilating the blood vessels, meaning opening them up to make them bigger so that more blood can flow through the blood vessels. And this blood is able to deliver oxygen and nutrients and remove metabolic waste. So it can actually improve your performance in the gym as well. Furthermore, it actually is able to lower blood pressure. So a lot of different supplements and actually pharmaceutical drugs are used to increase nitric oxide to decrease blood pressure. With that being said, we're going to move on to some diagrams where in this first diagram I will show just how nitric oxide is produced within the body, and then afterwards I'm going to show downstream effects of nitric oxide. So here I'm kind of depicting what's occurring in a smooth muscle cell in the walls of a blood vessel. So this kind of line shows the plasma membrane of the smooth muscle cell of a blood vessel, and similar to a normal muscle cell, a neurotransmitter called acetylcholine will help to communicate to the blood vessel whether it should contract or relax. And in a blood vessel, contracting the blood vessel will cause the blood vessel to constrict, so have a smaller diameter and a smaller circumference. And if the blood vessel relaxes, it will cause it to dilate and become wider so that more blood flow can move through that particular blood vessel. So in this case, acetylcholine will bind to a receptor on the wall of the blood vessel, of the smooth muscle of the blood vessel. This will activate this G protein, and then this G protein will release GTP to activate an enzyme called calmodulin, and calmodulin will activate endothelial nitric oxide synthase. And this is the primary enzyme that will synthesize nitric oxide. And nitric oxide synthase takes L-arginine and converts it into L-citrulline and nitric oxide. And it's able to do this by oxidizing L-arginine into L-citrulline and removing an oxygen from L-arginine and attaching it to a precursor of nitric oxide. Furthermore, this you can kind of understand why a lot of supplements contain L-arginine in an attempt to create more nitric oxide. Because the theory is if you overload this side of the reaction with a bunch of L-arginine, that it will force this enzyme to crank out more nitric oxide and more L-citrulline. However, in practical application, L-arginine is eaten up in first pass metabolism in the liver. So whenever you consume any kind of supplement or drug, the drug has to be kind of screened by the liver as just to make sure that it's safe for the body. And a lot of times the drug or compound is degraded because it's seen as a threat or because there are certain enzymes present in the liver that will degrade it. And L-arginine is degraded substantially by the liver, so ultimately not a lot of it reaches the bloodstream and it's not able to build up to get this desired effect of nitric oxide. However, in contrast, L-citrulline, when taken in a supplement form, is not degraded heavily by the liver, so it's very bioavailable, is able to build up in the body. And what happens actually is L-citrulline will build up, it will be converted backwards into L-arginine, and then this L-arginine will be converted into nitric oxide at a higher rate than if you just took a bunch of L-arginine. Moving on to this next diagram, we can see the downstream effects of nitric oxide and how it is able to ultimately relax the smooth muscles of the blood vessels, causing them to dilate. So once nitric oxide is created, it binds to an enzyme within the smooth muscle called guanylyl cyclase. And guanylyl cyclase converts GTP into cyclic GMP. This cyclic GMP then activates protein kinase G, and finally protein kinase G inhibits IP3 gated calcium channels, which are present on the sarcoplasmic reticulum. Now, if you haven't watched my muscle contraction physiology video, you probably won't understand why this would dilate your blood vessels. muscles. But this is important because calcium release from the sarcoplasmic reticulum is the first step in a muscle contraction. And that's because when calcium is released from the sarcoplasmic reticulum, it travels to the myofibril, which is the part of a muscle that controls the contraction and relaxation of the muscle. And the calcium binds to a protein on the thin filament of the myofibril called troponin, which is this little blue ball here. And troponin is able to move tropomyosin, which is shown as this thin purple string here, and it moves tropomyosin out of the way so that the thick filament of the myofibril can bind to the thin filament. And this is the first step in a muscle contraction, which is shown by the rest of the diagram. So like I said, go back and watch my video to get more of an idea of what's occurring here. But if calcium is not able to be released from the sarcoplasmic reticulum, like when there are high concentrations of nitric oxide, which cause all of its downstream effects, then ultimately calcium can never bind to troponin and no muscle contraction can occur. So the muscle will relax, causing the blood vessel to dilate or widen so that more blood flow can flow through that area, delivering more oxygen and more nutrients to the area. Going back to the previous diagram, I just want to point out the left side of the diagram, which will illustrate how Viagra or Cialis is also able to accomplish these downstream effects. So cyclic GMP can be degraded by an enzyme called phosphodiesterase, and the phosphodiesterase will convert cyclic GMP into an inactive form called GMP. And Viagra and Cialis actually bind to this enzyme and inhibit it so that's unable to degrade cyclic GMP. So if more cyclic GMP is able to build up in this reaction, then it can elicit even more activation of protein kinase G and its downstream effects, just like a buildup of nitric oxide would. So you can see from a variety of channels how ultimately blood vessels are able to dilate and accomplish the same effects through different drugs. It is important to note that in high concentrations, nitric oxide can be extremely dangerous, and that's because nitric oxide is a gas. Therefore, it is both hydrophobic and hydrophilic, so it's able to move through any tissue within the body and interact with any tissue readily. So in low concentrations, it acts how we want to. It increases blood flow by dilating the blood vessels. However, in high concentrations, it actually functions as a toxic molecule released by macrophages to kill invading pathogens like viruses or bacteria. So when it's released to kill viruses, it inhibits the viral protease that helps to chop up the cells so that the virus is unable to weaken a cell by chopping up its proteins. Whereas in bacteria, it inhibits the bacterial ribonucleotide reductase. It also inhibits DNA repair. So ultimately, the DNA of the bacteria is damaged. It's unable to properly make proteins, which means that it's unable to invade your body. That being said, it's important to know that if we have artificially high levels of nitric oxide and neither of these pathogens are present, it'll attack and damage our own cells. That's why it can be very dangerous.